Everybody's ready? Can we start? Or do you want to wait more time? No? It's okay? Okay, go. So today in this session, we are gonna to cover a new feature of Google AppEngine that currently is in beta, and it is Managed VM for Google AppEngine. So in this talk, we will see a description, an overview of about the Google AppEngine and Managed VM. We will see a demo of an application that is running currently in Google AppEngine and making use of Managed VM that is called USketch. It's a very, very simple application developed just for this particular talk. And in the end, we will see the more in details the different part of the code needed to set up a machine, define an instance on Compute Engine, etc. So it's okay. So we start. Let me present myself just 2 seconds. I'm Marco Tranquillin. I'm the cloud solution architect of Revevod, that is Google Premier Partner. We are based in France and in Italy. This year I became a Google Developer Expert for Google Cloud Platform, and I'm using to participate, to talk, to evangelize the new feature of the platform, Google Compute Engine, AppEngine, etc. So let's go inside the details about what we are going to see. So what are the difference between infrastructure as a service and platform as a service? When we want to start developing our application, we usually need to think about what will be the backend that we are going to use to implement our application. And we usually have two kind of strategy. We could decide to adopt a platform as a service that is commonly for the Google Cloud Platform is Google AppEngine, that is totally managed by Google. You don't have the opportunity to make any change on the backend of your application, on the virtual machine of your application. You have some setting that you can check, that you can control via the console, but is a platform totally provided by you, totally provided to you by Google, and it scales in an automatic way based on the number of requests that you are receiving, and is perfect for serving your application. But when you need to develop something more specific, and when you need to, for example, integrate other kind of tools that are not available on the platform as a service side, you need to rely on an infrastructure as a service side. So Google for that is providing Google Compute Engine that allow you to turn up every kind of instance that you want, Linux machine, Windows machine, and you can use every kind, and you can create a cluster, you can deploy your application, you can define your network, you can do everything you want. So you have 100% of flexibility when you use that kind of service. But what about having a mixture between the two? So what about having the flexibility of an infrastructure as a service and an automatic management of a platform as a service? This is the goal of the Managed VM feature that has been introduced by Google on Google AppEngine. Thanks to that service, you can have all the features that are available today in every Google AppEngine application. So every kind of API, every kind of service to store the data, etc. But you can run your particular instance in a machine that is hosted by Google Compute Engine. And thanks to that, you could have a lot of control, and you can integrate different kind of elements. For example, you can develop one part of the application using Java, Python, or Go language, as you usually do when you develop an application using Google AppEngine. But you can integrate also code that has been written, for example, in C++, or you can use a particular Unix tool that you can use only if you have the control of the machine. And this allows you to create, let me say, a mixture between the two kind of service, and allow you to have more control and allow you to implement very, very flexible application. From my point of view, this new feature is extremely amazing because you can think about a new world where everything you want to do, you can do it. So it's really, really something that it's really a new feature that is very, very important and very, very useful. I have to say to you that right now it's in beta, so don't use it for production application, but you can start using it immediately. Just go to the developer site of Google AppEngine, and there is a dedicated section called Managed VM where you can find a lot of information. So if you are developing your application using Java or Python, you will find really, really a lot of material for that kind of feature. What does it mean having an infrastructure as a service and a platform as a service mixed all together? It means that you are running the normal virtual machine of Google AppEngine in a compute engine machine. And what is the technology that Google is using in order to provide you with this kind of feature? Google is using Docker that allow you to, let me say, create an instance, a particular instance containing all the information, all the file needed to run Google AppEngine backend, and you can install that Docker instance into a specific machine in your Google Compute Engine environment. As we will see after, it's very powerful because you will have the opportunity to select the dimension, the type of the machine, the dimension of machine. So if you need to perform a particular computation that require a lot of memory, you could decide to use a machine with a lot of memory. Otherwise, if you need to perform a CPU-intensive computation, you could decide to choose a dedicated machine for that. A typical use case is for application that, for example, need to convert some video and that require a lot of CPU potential. So as I said, in order to start up your backend, your managed VM backend, you need to use Docker. If you are a Mac user or a Windows user, you need to use both to Docker. That is a tool that allows you to create a Docker instance and manage Docker instance inside your machine. It's very simple to do. You need to surf to the Docker website, download the tool, run the tool, and simply launch this kind of command from the command line. The first one is the command needed to start up the Docker environment to create the virtual machine needed to set up the different Docker cluster. And Docker PS allow you to see the number of operations that you have performed in Docker and the number different containers that you have. And the last one is the command that allow you to install from the Docker environment the virtual machine of Google AppEngine, the virtual machine of Google AppEngine needed to be installed inside a Google Compute Engine machine. So the application that I have prepared just to show you what we can do with this kind of technology, it's called USketch. It's a tool that allows you to upload a picture into the web, into a normal web page, and that tool will transform that page in a sort of sketch. So it will apply some filter into the picture just to extract the edge and to create a sketch from the picture. Why I have decided to implement this kind of feature? Because one of the most famous library that allow you today to perform every kind of image elaboration, video elaboration, etc., is called OpenCV, and generally you have to use C++ in order to get access to this kind of library. So what we have done, we have simply we have simply written a program in C++ that was able to get in input a raw image, perform the elaboration using OpenCV, and then give the in output the result, the picture. The mixture between the two components is that thanks to Google AppEngine, we have exposed immediately the application on the web. We have created a very, very straight integration with Google Cloud Storage to save all the picture uploaded by the user, send the picture to our Google Compute Engine, our Docker container running on Google Compute Engine that will make the conversion of the picture, and then the application running Google Compute Engine will get back the converted picture to the user. So I will show you. This is the result that we can get. If you want to try, just connect it to the website. I will show you in a second the atypical result. So this is the website. You could upload the picture. Maybe you upload the picture, and the system will send the picture on the back end. This is the typical mood that I have at the end of the day. So this is my picture. So you have uploaded the original picture on Google Cloud Storage. The back end will take the Google Cloud Storage information and get back to our application on the back end, apply the filter thanks to the C++ application, and then get back to the web. So this is something that was not possible before, and thanks to that, to this new feature, we are able to do also this kind of integration between the two words. So I wanted to go ahead. Okay, so what I would like to show you right now is how we can do that, how we can create an application that get access to this kind of feature. So in order to set up an application using Managed VM, you can use, as I did, for example, I have used a normal Maven archetype, a normal Google AppEngine application using the Maven archetype dedicated for Google AppEngine application. And then you have simply to modify your AppEngine web XML using the particular tags that will say to the AppEngine backend that that particular application will be an application making use of this kind of feature. So the first one is the first element that is important is to say, okay, this is an application that will make use of VM. So you have to simply set true, and during the compilation, the system will know that you are using this kind of element. Then there are two particular settings that are available only using this beta feature, that are the machine type and Java Quick Start. The Java Quick Start allow you to get access to a new version of the servlet, so the servlet 3.1, that are not available in a normal Google AppEngine application if you are using Java, for example. So it's very useful because you don't need, for example, to write a web XML file very complex. You can use annotation directly on your server, so it will speed up a lot the development of your application. And this is one of the most important elements, that is the machine type that you have to use. So you have to simply put the value that is the one that you can find in the official Google Compute Engine documentation. If you look at the At that page, you will see the list of all machines available for you in the Google Compute Engine environment, and so you can decide which kind of machine you want. But as we said before, we want to have a mixture between the pros of two environments, so the pros from PaaS and the pros from IaaS. So what is the main feature of Google App Engine? Is the ability to scale the number of the backend instance in an automatic way. So thanks to that configuration, we can have similar behavior using Google Compute Engine. We could here define the number of minimum and maximum instance that could have our application. And we could also decide the time needed to shut down an instance if the instance is not used anymore, and the percentage of usage of the CPU of an instance that is needed in order to say, okay, I'm using 50% of the CPU power of my instance, so I need to scale. I need to have another instance. I need that the backend will provide me with another instance in order to complete my job. So thanks to that configuration, you are able to complete everything. Of course, if you don't want to have an automatic scaling, you could always decide for manual scaling. Instead of writing automatic scaling, you will write manual scaling, and you will have simply to write the number of instances that you want to have. As I said before, this kind of technology make use an extensive use of Docker technology. Sorry, of Docker technology, and the base image that you are going to use when you start implementing this kind of application is called, of course, AppEngine Java if you're using Java. Otherwise, you will call AppEngine Python if you're using Python. And one of the most important things is that you can extend the Docker image when you are going to deploy your application. Why? Because maybe you need to have more operation available on the machine, more information, more tool available. And this is what we have done for our application. We have implemented our C++ image converter. And then we have pushed that application on Google Cloud Storage. So every time we spin up a machine, the machine will start from the base image for the base Docker image of Google App Engine. We'll perform an update. We'll install the wget application, the Linux wget application needed to download the information from Google Cloud Storage. I made it public because I mean there is no problem in making public our application. So we said, okay, copy the application downloaded in USR bin, changing the attribute in order to allow the end user to execute the application, and then that's it. And then complete the Docker image. So the first time when you deploy the first time your application, the system will create a dedicated instance on the Compute Engine environment. It will install Docker on top of that on that instance, and will execute all the steps that you have written inside your Docker file that you are going to deploy in the application. So if you want to get access to your machine, and if you want to see what has been done, as we will see after, you can do it without any kind of problem. Okay, so we have seen a global overview, and then we can dig inside the code. So we could start from here. So this is the application, so it's a normal Java application. Here we have a normal index file with all the features needed to interact with Google Cloud Storage, with all the things that we need in order to manage authentication, etc. So the most important thing that I would like to show you right now is, as we've seen before, is the AppEngine Web XML. So it's a normal AppEngine Web XML file. You need only to add this kind of stuff. For this particular application, I decided to put one single machine, so I have written manual scaling, instance 1, and that's it. For the other part, I have enabled the debug just to debug the application on local when I run it from locally. And that's it. This is the Docker file that we have seen. So here you can write every kind of information that you want to execute during the startup of your machine in the Google Compute Engine environment. And this is the servlet that will receive the information from the web, and that will be executed inside the machine in the Docker machine on Google Compute Engine. So as you can see, we are using the web servlet annotation coming from servlet 3.1, and we are writing a normal servlet. What is important? What's the difference between with the normal servlet is the fact that you can interact with the file system of the machine. It's like to implement a client application, but you are running this application using Google App Engine as the backend. So as you can see here, the application is receiving the input file name. Sorry, here is receiving the input file name as a parameter of the post. It downloads the object from Google Cloud Storage. It prepared the output. It prepared the argument that will be passed to the C++ application that we have written, and we execute the process. Once the process will be executed, we upload the file generated to the Google Cloud Storage, and then we come back to the web session. And the web session, when receive the output name here, the output name from this servlet, it will download the file from Google Cloud Storage, and it will display it inside the web page. So the other class are the normal class to interact with Google Cloud Storage. So nothing particular important. Okay. I have to figure out where are the code. Okay, this is the C++ application. So as you can see, it's very straight. Nothing particular complex. You have all the elements needed to interact with OpenCV. At this stage, it will, once the application has received the input file, it launches a function to transform the input binary data of the image. It will apply a median blur, a Laplacian, etc., and will return back the application. So. I have to come back, here. Okay, so I would like to show you what's happened when we start when we want to, for example, load the application locally. So this is my Docker environment, the bot2 Docker environment. So I can look at the number of containers that right now are present, and so right now is an empty Docker environment. So I'm gonna launch the application from the command line. I hope that I'm already in the correct folder. Okay. Using Maven, I will launch the goal gcloud.run, and the application will create a new container on my Docker environment, and in that Docker environment, I will be all the code will be put inside my Docker environment, and I will be able to interact with it. So as you can see here, this container has been created, and the application is normally accessible on the localhost 8080. If I go back here on the container, I can see that there is exactly my new container. So a new image has been created. The last command that has been launched in that container is the Jetty server. And if I surf on my localhost 8080, I can easily get access to my application, normal application. What about if I want to deploy my application? First of all, I have to stop. So gcloud run stop. What about if I want to deploy the application? Thanks to Maven and thanks to the new version of gcloud that is available on the official website, the gcloud SDK, everything is you don't need to do quite nothing. You have to simply think about your application, write the code for your application, and then simply write mvn gcloud deploy. It will create for you the instance that as you have configured in your file into Google Compute Engine backend, and as we will see, you will be able also to get access inside of that instance, and also to get access to the Docker instance that is present inside your Google Compute Engine environment. I don't waste time right now in deploying the application, but I want to show you the backend accessible from Google Compute Engine console. So this is the console of my application. As you can see, maybe I can zoom a little bit. Okay, as you can see, we are inside the instance and in the instance of Google AppEngine, and Google has created for me this Google AppEngine, the full managed VM. If I click on Compute Engine, I will see exactly the same machine. Here it is, the same machine, because I have my backend, my application is an AppEngine application, but is running on Google Compute Engine. If I click on the application just to see the details of that application, I can see one important thing. This one, that is managed by Google. What does it mean? It means that if you try to connect inside to that machine and you try to connect to the Docker instance running on that machine, you are not able to do, because Google say to you, no, this is an instance that is managed by me. I assure you that everything is fine. There is no problem in terms of code. There is no problem in terms of consistency of the Docker instance that is running on top of it. So you cannot change anything. But what about if I would like to get access to my application and to see what are the different files that are present? Every time you can simply change here and say managed by Google, managed by user. It will appear this pop-up that will tell you, okay, you are changing the manager of the machine. You are getting access to the machine. So you can do everything you want, but when you will decide in the future to come back to the Google, to Google as manager, I will reboot the machine for you, because I have to be sure that when in the machine is written managed by Google, everything has to be correctly managed by Google. So if you have performed some modification, if you have performed some changes, Google will revert everything to the original version. Of course, if you want, you can always decide to put all your machine as managed by yourself. Google will not stop serving your application if you make a switch, but if you decide to come back, Google will revert everything to the original state. So we decide to click on managed by user. Okay, right now is managed by me. So as you can see, you can edit everything. You can edit also the external IP. So if you have a fixed IP, you can decide to put a fixed IP to your application. it's a normal Google Compute Engine instance, so you can do everything you want. You can create also, you can put this instance behind a load balancer. You can set up some auto-scaling politics. You can do everything you want. You can change, for example, the policies about the availability. So if you need to perform an automatic restart, or if there is any maintenance, you have to terminate the machine or migrate to another zone. So you can do everything you want. But let's try to get access to the machine. So we are accessing to the machine. Every time, as you know, every time you access through the web to the machine, you have access to the root level. So every time you can perform a sudo command to manage everything you want. So for example, this is my machine, and I want to see which kind of file are present inside my machine. So I go to home, just to see. I can see only my name, because I am connected to using my name, VM agent, and VM runtime app. But what I've told you before, the application is not running inside the machine, but it is running inside a Docker instance that is running on top of your machine. So we need to access to Docker in order to see what is working. So we write sudo docker ps, and here we can see that we have different elements that have been done, and this is the container ID of our machine. So what about if I want to get access, so inside to this machine? I need to send a command to this Docker machine, for example, getting access to the bash shell, to get access to the file, to see what's happening, etc. So we can write sudo exec container, the name of the container, and then bin bash. It's not exec container. I forgot, sorry. I have to see the, I don't remember because I forgot totally. This is just, it's important because I would like to show you where you can find all the information about Google Managed VM. This is the official website of Google AppEngine, and here you can find every kind of information that you want. This is a page that will show you an overview about the architecture that is behind this technology. And here there is a page that is called Access to the Host Environment that describes what we have seen, so the difference between machine managed by Google and machine managed by user. And in the end, there is the command that is container exec. So sudo container exec, I write the ID of my container, bin bash, and right now, as you can see, I'm inside the Docker instance of my machine. So if I perform a list, I can see everything. So we can enter, for example, inside the home, VM agent. I can see, for example, AppEngine Java VM runtime, and we can get access physically to all the file of our Google AppEngine application. It's like having the opportunity to get access to the backend of the AppEngine instance that you are used to see in the setting page of your Google AppEngine application. If we write cd web apps, we can enter inside the root, and here you can find exactly all the files that have been provided by me to the application. So this is the C++ application that we downloaded through the Docker file, and then we moved also to the USR bin usketch, right? Exactly, and we move that in that folder just to make it available everywhere. This is all the folder of my, as you can see, of my application. So we have all the class, we have jQuery file upload, index, images, Docker file, etc. We have all our application here. So if you want, for example, change some content, or if you want to provide new input data to your application, you can do it like a normal application that is running on your server, in your physical server, but you are relying on Google App Engine. This application, this feature, of course, is not very important for this particular kind of application. But if you think about, for example, to some features that are not available on Google App Engine right now because you have some classes, some Java classes that are blacklisted. If you are using this kind of feature, you can overcome this limit. So you can have access to all the scope of Java Virtual Machine. A typical situation is when you want to use Apache, some library from Apache to generate some Excel file, or if you want to convert some data from one format to another one. Sometimes it's very difficult to manage this kind of application using Google App Engine. And if you want, for example, create an application that is fully integrated with Drive, and you have some customer or some people that are asking you, okay, it's very cool, I have uploaded my Excel file into Google Drive, I would like to extract, I would like to read some information from that Excel file in an automatic way, to generate a CSV, to generate something else. I would like also to perform an SFTP of that file to another machine. It's very complicated to do everything today without this kind of feature. You can do it, of course, but you have, for example, to implement your web server on Google Compute Engine machine that is able to talk directly with your Google App Engine instance. Instead, having this kind of operation, you can mix everything in one single application. So it will speed up your development, of course, and it will open to you really a lot of opportunities. Nevertheless, there is the opportunity to use Socket because you have a physical machine. So if you want to create, to set up a physical connection between a machine and a device, you can do it in a very, very easy way using this kind of feature. So I think that I think that I have finished. So if you have some question, just tell me, and I will get back to you if I'm able, of course. Do you have question? Is it?
What is the list of available Docker file for AppEngine? Imagine you want to use the official Docker file for Node.js, for example.
Mm-hmm.
Can you do that?
Yeah. It's there is I will like to show you that in the exactly for Node.js. There is a great example in the documentation. Here, custom runtime. There is a page. There is a video made by the girl that is behind you. So I strongly encourage you to read that page and to have a look on this video, because it will explain you how you can define exactly your backend, your Docker file needed to set up every kind of application that you want. And there is a clear example here for Node.js. So yes, it's definitely possible. Other question?
Is the beta over soon?
Right now, I don't have any kind of data. I hope that everything will be released during this year, but I don't have any official information. I'm sure that as soon as it will be released, I will find really a lot of opportunities to use it, because I have a lot of customers that are asking me how to integrate the Google Cloud Platform with Socket, for example, and how to perform massive conversion of file. And using this kind of technology will be very, very easy to do. Very, very easy.
feature of AppEngine?
Yes, of course, because as you can see, the idea of Google right now is to make a sort of integration of all their all the infrastructure. So we have infrastructure of the service on the side, platform on the service on the side, on the other side, and in the middle we have a container as a service. So thanks to that container as a service, we have the ability to merge the two words, making one single word with every feature available. So this is for sure the future of all your application. Sorry, another thing that is very important. When you decide to use this kind of technology, it doesn't mean that you need to have all your backend of your application, all the module of your application running inside Google Compute Engine. You can have a mixture of the two. So you could have, for example, the front-end part of your application that will be served by the normal Google AppEngine backend that is extremely fast, is perfect for doing this kind of stuff. But if you have to perform, for example, some EV job operation, some batch operation, as you know, Google AppEngine is not very good in doing this kind of operation. So you could create dedicated machine for performing batch operation, making an integration with the front-end machine, and you have everything managed in one single application. Instead, right now, you have to have different application and create some bridge